Tech Pro. Today we'll be talking about abusing the cloud for command and control. My name is Dagmawi and I'll be giving this talk today. Without further ado, let's get going. By way of introduction, I am Dagmawi Mulugeta. I'm currently a threat researcher at Netskope. Previously, I've held positions as a researcher, software engineer, developer, multiple companies. I have my master's in cybersecurity from Drexel University, and I also have an offensive security certified professional certification. My interests range from CTFs, exploit development, and abuse of cloud applications as well. Today we'll be planning on covering 5 particular questions around Cloud C2. First, we'll start by talking about what Cloud C2 is, and then we'll go over what cloud applications have been abused for C2 or command and control, and then we'll go dive into 2 specific examples. The first with Dropbox and the second with GitHub, and we'll talk about how attackers might use these 2 applications to covertly send commands back and forth, and then we will end this talk by talking about defenses. So what exactly can we do in corporate networks to identify this sort of traffic and stay secure? So let's start with the first question, right? What is Cloud C2? Before we dive into Cloud C2, let's talk a little bit about what command and control is. So command and control is a stage in the cyber kill chain. As you can see in the visualization on the right, the cyber kill chain was introduced by Lockheed Martin, and it outlines the steps an attacker uses to infiltrate a particular victim's network. So it starts with reconnaissance. You gather information like emails, passwords that have been exposed in breaches, etc., and then you use that information to weaponize a deliverable payload, and then you go into the third stage, which is delivery of that particular payload, and that payload will exploit a weakness that you've identified through the reconnaissance phase. And once you've exploited a particular weakness, the next step is to install a backdoor or malware on an asset. Once you've installed this malware on the asset, this malware's job is to take in tasks or commands from an attacker-controlled environment or system. It'll execute it on the victim system and send the results back. This network communication is what we'll refer to as command and control, right? So it's the last stage in the cyber kill chain before actions on objectives, which is essentially getting what the main mission was for the attacker, getting those crown jewels, installing ransomware, whatever that might be. But before that, you do have to set up that command and control, that back and forth communication, which we'll refer to as command and control. Traditionally, it involves a compromised device polling a server for commands, and then executing those commands and returning the results back to an attacker-controlled server. Traditionally, it's used mediums like HTTPS and DNS directly to the attacker-controlled server. And popular frameworks that perform this task include Cobalt Strike and PowerShell Empire. So if you're not too familiar with command and control, but you are familiar with these 2 tools, that's what that's the stage in the cyber kill chain they would operate in. Cool. So what exactly is Cloud C2 now that we've defined what cloud command and control is, right? So traditional C2 is set up on the top right. You can see it's a compromised device polling back to an attacker-controlled infrastructure, right? So this attacker-owned infrastructure has been set up by the attacker themselves. So they've set up their own servers, their own domains if they need to, that will essentially be the place where an asset will reach out to once they've been compromised to pull for commands, right? So this is tough to detect, especially with tools that we've mentioned in the previous slide like Cobalt Strike and Empire, but it can still be identified by threat intelligence, good threat intelligence, and IP and domain block lists. So what is Cloud C2? So Cloud C2, opposed to traditional C2, uses cloud applications as a medium for these command and control traffic, right? So it requires very minimal setup relative to traditional C2, since most of these apps will have a quick start process that attackers can go to quickly set up an application. And they usually come with TLS and SSL, so all that traffic is normally encrypted. And it's tougher to detect from a defender point of view because all of this traffic is going to domains that normal traffic in your network might already be going to, because these are popular applications that most people will use, especially given the remote work we've all had to endure the past few years, right? So that's what Cloud C2 is in a nutshell. So next, let's talk a little bit about what the technique is in MITRE ATT&CK. So technique 1102 is called abusing web services for command and control, which is what we refer to as Cloud C2. It's the same concept, right? MITRE ATT&CK does a really good job of breaking it down into sub-techniques. So sub-technique number one is a dead drop resolver. So if you're pretty familiar with espionage, then you kind of have the concept of a dead drop already. In command and control, or abusing cloud apps for command and control, a dead drop resolver is an already pre-agreed upon location an asset or a compromised asset can reach out to grab where the next step of the compromise should be, right? Like, so where it should reach out to for command. In the screen, we have an example of a YouTube comment, and this person started out by typing out "my keyboard doesn't work" and then a bunch of gibberish. But then on the second line is a base64 encoded endpoint that the malware sample should reach out to. So the malware sample will reach out to this YouTube comment, grab that text, base64 decoded, and reach out to that endpoint, right? Sub-technique number two is one-way communication. So this is the case where a compromised asset will reach out to a cloud application or a normal web service, grab a command, run the command, but won't return the output. So it's only one way. It's only from the attacker to the compromised asset. The asset will execute those commands, and then that's kind of the end of that communication. On the other hand, the third sub-technique is bidirectional communication, where the attacker will send commands via a legitimate web service by abusing a legitimate web service, and the compromised asset will return the results via that same via that same cloud application that's being abused, right? So it's the communication is both ways, and that's for the rest of this talk. We'll really focus on the third step technique, which is the bidirectional communication, and we'll kind of see what has been happening in that space as well. So we've just talked about what Cloud C2 is, right? Cloud C2 is command and control network communication happening via cloud application. So let's dive a little bit into which apps are being abused for command and control. So we've picked a few examples that are fairly recent that we found to be really, really interesting, and have abused the cloud apps in a rather interesting fashion that we kind of dive into them a little bit here. So this example is from December 2021. So at the time of this recording, it's 2 months back. This malware sample by the name of Aclip was abusing Slack's API for command and control. And it was really interesting because it was sending data across multiple channels. So on the first channel, it would download commands and then return the results via a different channel, and even upload files via that channel. But then system information was sent through a different channel, right? So it was using features that were native to the cloud application. So Slack is popular workspace collaboration application that has different channels for different topics people want to talk about, and the malware sample was actually leveraging this flexibility to send data back and forth and kind of blend into normal traffic there. So the second example is Dropbox. So Dropbox, this particular example was from January 2022 that was abusing the cloud storage app Dropbox for command and control. So the threat actor by the name of MoleRats, right? They were abusing, kind of following a very popular flow that we're seeing today. Malicious Office document contains some malicious code. Victim downloads it, executes that, or opens the malicious Office document that executes that malicious code. In this case, it runs a PowerShell command line that downloads and executes a backdoor that was using one Dropbox account for command and control, another Dropbox for file exfiltration, and he used up to 5 different Dropbox accounts to kind of send information back and forth from the attacker to the victim's network, right? So it kind of, again, it leveraged the flexibility that Dropbox provided by being a very easy to use cloud storage application, kind of send commands back and forth, right? The third application is Office 365. In this particular example, we focused on OneDrive, which is part of Office 365. And the sample, again, from January 2022, at the time of this recording, a month ago, malware sample named Graphite was abusing OneDrive for command and control. So again, very similar flow, right? Malicious Office document gets downloaded, runs some malicious code, right? Download some more malware. In this case, it reaches to Graphite, which uses OneDrive for command and control. So it sends victim information back, receives additional malware, and the attack chain continues. It will finish the attack chain to download an Empire PowerShell stager, right? So the attacker here was just really trying to get set up in the easiest way possible. Again, leveraging that flexibility in that application to send data back and forth, right? And finally, we have Google. And just to switch gears a little bit and talk about an attack tool instead of malware, we have an example here called GC2, right? So GC2 is a tool, an offensive tool that abuses Google Sheets and Google Drive to execute commands on its victim. So you can see the victim will pull commands every 5 seconds from Google Sheets. It gets a new command, executes that command, returns the results via to the Google Sheet, or even upload files to a Google Drive and exfiltrate data, right? So this attack flow is it's very kind of symbolic of what we're saying, where attackers are leveraging that flexibility in the cloud application, right? In this case, it's Google Sheets and Google Drive, very popular, very easy to use cloud applications to move data. The attacker is going to use it to do the same thing and blend into normal traffic, right? And there's many more examples of this. We just don't have time to dive into each one in depth, but we can, there's abuse happening to GitHub, to Twitter, to Tumblr, Blogspot, Google Docs, OneHub, Telegram. Like, all of these apps can be abused for command and control traffic, and they have a very prevalent adversaries are currently abusing them today, right? And if you're curious to see more about these articles, there's a MITRE page that we've kind of brought up earlier in the talk that you can definitely go to, that has a very that has a curated list. Cool. So we've talked about what Cloud C2 is. We've talked about which cloud apps are abused for C2, which are a lot of them, right? So now let's talk about, well, why do attackers do this? Like, how easy is this to do, let's say, with Dropbox, right? So in this example, in this talk, we wanted to dive a little bit into Dropbox abuse, right? So Dropbox abuse specifically for command and control. We will follow the steps outlined by BC Security, which are the creators of Empire, or the maintainers of Empire, I should say. And our setup was an attacker victim setup, both in AWS. Attacker machine was set up in EC2 using a Kali image, so it's a Kali machine, and the victim setup was a Windows machine in AWS workspaces, right? So everything in the cloud. The steps we're going to follow are fivefold. First, we're going to create an attacker-controlled Dropbox account. Second, we're going to set up an Empire server with a listener that has an access token from the Dropbox account we created. Third, we're going to generate a malicious payload that contains that token to be deployed on a victim. Step 4, we will deliver the payload directly to simulate a compromise. This step, in the real world, this would be where the attacker would host the payload, have a malicious link in a Word document or an Excel document, and deliver that via phishing email, right? In this case, we're just going to leave all that fluff out and directly deliver the payload to the victim machine. And then finally, step 5, we're going to interact with the compromised device and see how easy it is to send commands and receive results back and forth via this Dropbox account, right? So in the diagram on the right side, you can kind of see what that flow looks like. You have the Empire sending commands to the attacker-controlled Dropbox account, get sent to the victim computer via this agent. The agent runs the commands, uploads the results to the Dropbox account, and then Empire will read these results back, right? So step one, let's create this Dropbox account, right? So takes 5 minutes. Dropbox, very easy to use, right? You sign up for a free account, and then once you do, you can choose a scoped access token. In this case, we'll name it. We'll name the app Empire C2. You need to create an app to create an access token, and then we will download this token for later use, right? So that's the first step. Second step is we're going to set up Empire on our Kali machine with an access token from Dropbox, right? So here we set up Empire. We set up a Dropbox listener. In this case, we've told it the results folder should be results, staging should be staging, tasking should be tasking, right? And there's some additional configurations you can use to kind of tune it how you'd like it to appear. In this case, we've left it mostly with the defaults, and then we will set the API token that we grabbed from the previous setup with the Dropbox account, right? Once we set that up, we execute it, we can see Dropbox is listening successfully, right? Whole process took under 10 minutes, right? So what does that do? Once you've set up a Dropbox listener, Empire will go into your Dropbox account via that API token, and it will create a folder named Empire. In this case, we've named it Empire, but this is configurable. And under that folder, there's a results, staging, and taskings folder that have been created for you. So this is kind of laying that, kind of foreshadowing, laying the scenes for that traffic that's about to go back and forth to a compromised system. So once we've set up the listener, next we're going to have to generate this payload that contains the token, right? This payload in Empire is called a stager. We're going to use a specific type of stager called we're going to use a specific type of stager called a Windows batch file, right? So Windows launcher batch, and we are going to embed that token. We're going to say this is going to talk back to our Dropbox listener, and once we have generated that batch file, we're going to host it with a simple Python web server to be downloaded on our victim machine, right? And then once we've hosted that on our victim machine, we'll download that batch file and execute it. This will create a PowerShell process for us on the victim machine, right? And this process actually talks back to the Empire listener via Dropbox. So after a few seconds, you can see in our attacker machine, we have a new agent, right? So an agent is basically a process running on a compromised device from an Empire point of view, right? And you can see it's using PowerShell. You can see the IP address, the username, right? What process ID, and most importantly, what listener is this agent talking to, which is Dropbox. Finally, once we have all of this set up, what's left is just interact with the compromised device, right? We can write popular commands, right? Like, who am I? List the processes, give me a screenshot, and we'll get these outputs back fairly quickly, right? Like Dagmawi Mulugeta, here are the processes, we've saved a screenshot, right? So we'll get all these results back via Dropbox. So all this interaction is happening through that Dropbox account, right? And if we take a look at the Dropbox account and list the file history, we can see that this interaction happened by uploading and downloading these task files. So that's how Empire is doing this behind the scenes, right? So it's uploading a task file, victim reads the task file, deletes it, uploads the results from the task, Empire listener grabs those results, deletes those results, and this whole step is repeated over and over again for every command. Cool. So that's how easy it is to do with Dropbox, right? It's fairly simple. It as an attacker that's quickly trying to get set up and blend into traffic, especially if the victim enterprise is using Dropbox, that's a very attractive approach, right? So let's talk about GitHub a little bit and see how easy it is to do there. So very similar approach. We're going to use a tool called C3 in this case. Instead of Empire, and we're going to follow the steps outlined by F-Secure. So F-Secure is the creator of C3, right? C3 stands for Custom Command and Control. And in this case, both the attacker and victim machine are set up in AWS workspaces. So they're both Windows machines, right? And again, we're going to follow a 5-step process here. First, we're going to sign up for a GitHub account and create a personal token, right? Second, we're going to set up C3 with a GitHub channel, and then we're going to pass that personal token in. And then thirdly, we are going to set up a C3 payload, like a malicious payload that contains this GitHub token to be delivered to a victim machine. And then once we have that, we are going to download it and run it on the victim machine to simulate a compromise, right? That's step 4. Now, normally in the real world, an attacker would host a phishing page that has like a Word document that has some malicious macros that will run on the victim machine to download this. We're going to skip all that fluff for now and just focus on the cloud command and control piece here. So the 5th step is, once we have everything set up, we'll interact with the compromised device by sending commands through GitHub, right? So you can see on the screen, that's kind of what we're doing. C3 sends commands to GitHub account. The victim machine has a processor agent, a relay, which is the correct terminology for C3, right? Has a relay running that will pull these commands, execute the tasks, and upload the results to get to the GitHub account that C3 will pull and show. So, all right, first step, sign up for a GitHub account. Again, like Dropbox, very simple to use, right? These SaaS apps have done a very good job of making it easy and seamless to get set up. So you create your account, set up your token, and in this case, we've named it C3, and you download that and save it for later use. Right, once you have that token, we're gonna go set up C3 with a GitHub channel, right? In the C3 server. So in Empire, it's called a listener. In C3, it's called a gateway. So we're gonna set up the gateway to be GitHub. We're gonna give it a few parameters like a negotiation identifier, the GitHub token that we've used from the previous step to get set up, a repo name or repository name, and then a user agent header, right? So once you pass these parameters and you create the gateway, it'll kind of look like the bottom right where the gateway set up and you have all these channels that you've set up, right? So once you've done this on the GitHub side, what it does is it'll create the repository, based on the name you gave it, to be used for the C2 channel, right? And this is happening in the GitHub account you created the token for. So you see, in this case, it's DE5J. That's what we gave it. That's the repo name, right? Once we have this, the next step is to set up a C3 payload that contains the GitHub token. So a lot of these fields have already been pre-populated from the previous step, but you can see that what we're shooting for is an executable for x64 architecture via the GitHub channel we created. And there is an input and output ID, which we'll get back to in just a second, but these special identifiers are in place. And then you have the GitHub token, the repository name that was created, and then the user agent header that's already been pre-populated from the previous step, right? So now that we have all these values in place, we're going to create and download the relay, which is the agent that's going to be running on the victim machine. And we are going to deliver it to the victim, right? So in this case, we download it directly to the victim machine, and then we're going to run it to simulate a compromise. And once we do that, a relay is going to appear in C3, which has a really cool way of visualizing what's happening. And you can see that it grabs all this useful information for us, right? So for an attacker, rather. So you have the computer name, the host name, you have the username, the domain, the process ID. Is this an elevated process? In this case, it is, because we ran it as admin, and then you have other useful OS information as well, right? So all of this is happening by sending data over GitHub. So there's no other mediums that it's sending data by, right? And if we take a deeper look into what happens in the GitHub account, right? So the first step is an attacker commits to the repo. So if you remember earlier, we talked about an input and output ID. That's how this tool can tell between tasks that have been uploaded by the C3 server versus results from the relay, right? The victim machine, right? So the input ID is the prefix. So if you see it's MTX up to the hyphen, that's the input ID. Those are files that have been committed by the attacker, right? So the victim will pull these files down, they'll run it, and they will delete the file from the repo, and then they'll upload the results to the repo with an output ID prefixing that commit, right? Sorry, that file name in the commit, right? And once they've uploaded this, the attacker will download it, delete it, and read it on processor, right? And this happens and this is repeated for every command that is run via this tool, right? Cool. So we've talked about what Cloud C2 is, right? We've talked about what Cloud Apps are abused by Cloud C2, and we've given two examples, one via Dropbox and one via GitHub, for why it's easy to use these apps for command and control. Now, finally, let's talk about what the defenses could be, right? So what can people do to prevent detect and identify these cloud application abuses? So the first thing people should do is block all known malware, right? So and this can happen at the endpoint, or if you have a network solution, just try to prevent all the previous stages in an attack kill chain is really the best way to prevent cloud command and control, right? But barring that, there is stuff that does get through. So what can you do after that point, right? So any unsigned applications making network connections is something that warrants further investigation. In the screenshot here, we have a capture from a tool called Fiddler, which is an HTTP proxy running on the victim machine, and you can see this sample, this relay.exe, was reaching out to GitHub to GitHub repos for commands, right? That's very strange behavior for an application that's unsigned, right? So that's something you definitely want to flag. And finally, beaconing behavior, definitely something that's a giveaway, right? So here, every few seconds, this relay.exe was reaching out to GitHub, particularly this repo, for commands. So it was polling all the time. That's definitely something you can identify on, and if you see that happening for an application you've never seen before in your network, that's a red flag, right? That's something you want to dive into. Fourthly is unusual user agents associated with known malware, right? So here on the screen cap on the bottom left, you can see the user agent is Windows 11, Internet Explorer on a very old Windows version, right? That's something that is weird, and not only is it weird, it's also associated with Empire. Huge giveaway there. So that's a lot of these attackers might not be following the best operational security practices. So that's definitely something that you can use to your advantage as a defender to identify these sorts of attacks on your system, right? And the last two are actually from F-Secure, where they've talked about how you can identify C3. And the first is packet count anomaly. So you can see in the screen cap on the right bottom side, a compromised Slack application, malicious Slack application that is beaconing out or phoning home via Slack behaves very differently from normal applications on network via their packet count. So you can see that a compromised endpoint, it reaches out to Slack in a very defined manner across time, and it's always the same set of packets that are transmitted, right? So that's a very good thing to use to identify this sort of traffic in your network. And lastly, actions on objectives, including data exfiltration over the C2 channel. Huge thing you want to be on the lookout for, because once these the command and control itself, if there's no commands back and forth, might be tough to detect. Once there's commands to exfiltrate data, to deploy ransomware, and perform all these other actions, that's definitely going to be something you can use to your advantage as a defender to identify this cloud communication, or this communication happening over cloud applications. Cool. So let's take a step back and talk through all the points we've covered, right? So we started out with talking about what Cloud C2 is, right? So Cloud C2 is command and control that happens via cloud application. We've defined what command and control is, we defined what Cloud C2 is, and we defined what the MITRE definitions are or sub-techniques are for cloud command and control. Then we moved over to and talked about what cloud applications are being abused for C2. And the short answer is a lot of them are, right? A lot of them are very easy to use. They have amazing flexibility today, especially with everyone working remotely. These SaaS apps have grown to be very ubiquitous. So attackers are going to capitalize on this, right? They're going to say, okay, let's no reason for us to start from scratch and do it worse. Let's capitalize on some of these applications already in place, right? And then we moved over and talked about how Empire can be used to leverage Dropbox for command and control, right? And then we talked about how C3 can be used to leverage GitHub, and we talked about in both of these examples how easy it is to get set up and how tough it would be for someone to identify the sort of traffic happening, right? And then finally, we talked about what defenses can be put in place, and we listed out some ways you can identify C2 over cloud application so that you're better protected as a defender in your enterprise network. So that's all we have for you for Cloud C2 today. Thank you all for attending this talk. If you have any questions, you would like to know more about what we're doing here at Netskope, or you just want to reach out and talk anything cybersecurity, my Twitter handle is at DAGMULU. My LinkedIn is Mulugeta, and we'll have a bunch of updates regarding Cloud C2 this year and next and in the future on our blog at Netskope Threat Lab. So please reach out at any of these mediums. We'll be happy to talk about. And that's all. I hope you have a great time and enjoy the rest of this conference, and I hope you stay safe.